Okay, reviewing definitions. And I know if you guys were here on Saturday in doing some of the reactions, we kind of covered this already and reviewed oxidation and reduction. But just so you have it again in your notes for this chapter. Oxidation, are we gaining or losing electrons with oxidation? We're losing electrons, which means that the charge, you can think about it a couple different ways. The charge goes up. With reduction, we're gaining electrons. The charge goes down. We're reducing the charge, right? You can think about it that way. Also, you can remember this, and we talked about it on Saturday if you were here. Leo, do you remember this? Leo, I don't know, it could be the lion or whatever, goes what? Grr. So, you can remember oxidation is losing electrons, reduction is gaining electrons. Okay? So that's just kind of a little helpful hint there. There'll be another one sooner to help you remember. Okay, now reducing agents and oxidizing agents. You need to know basically that the reducing agent is donating electrons, and it's basically the thing that's being oxidized because it's reducing something else by giving away its electrons. Okay, so the reducing agent is the one that's also being oxidized. The oxidizing agent is accepting electrons. And since it's accepting electrons, it's the thing that's being reduced. Okay. Just a quick vocabulary review. Next, oxidation numbers. A lot of the questions on the reaction section, if it's a redox reaction, will ask you how the oxidation numbers have changed from one side of the reaction to the other. So it's important that you can figure out oxidation numbers. And important for you to memorize like the most common oxidation numbers, mainly hydrogen and oxygen. Oxygen always has an oxidation number of what? -2, right? And hydrogen always has an oxidation number of +1. So I've got to think about, since I've got 3 oxygens here, then this is like -6, this is +1, and so you would need to figure out the charge of the nitrogen to make the entire thing have a charge of 0. And so it would need to have an oxidation number of +5, so that I end up with +6 and -6. Okay, if you have something like lead sulfate, I've got oxygen, I know that's always -2 times 4, so that's -8. How do I know what the lead is? Or what do you think lead would be? Yeah, +2. Why do you think it would be +2? Yeah, because SO4 together is -2. And since I've only got one sulfate ion, then that means it had to be the lead 2 ion, so that charge is +2. Oh, this should be -8. So then my sulfur here has to be +6. Okay, remember those? All right, also, this is the last review thing, balancing half reactions. If you are given, I'm going to do the whole reaction first, and then we'll split it up and review the steps for balancing the half reactions. Electrochemistry is all about the half reactions, so we want to understand this pretty well. Okay, so I've got solid aluminum. It's being oxidized to aluminum 3+. Permanganate ion turning into just manganese. ion plus 2. Okay, so I've got to separate these into half reactions first. The easiest one is my aluminum here, and that is turning into aluminum 3 plus, and also 3 electrons. Okay, that one's easy to balance because there's no oxygens or hydrogens or anything to worry about. All I have to do is balance the charges by putting the 3 electrons over here so that both sides have a charge of 0. Okay? The other half reaction would be my MnO4 going to Mn2 plus. Now, when you're going through and balancing these, you want to balance the elements first. I've got 1 of each of the manganese atoms. What's my next step? I have to balance what next? Oxygens with waters, right? So now I want to add 4 waters over here to give me 4 oxygens. I've got 4 oxygens over there still. Next step is to balance hydrogens. I need 8 of them. Put those there. And then I can balance charges. So over here I've got a plus 7 charge. Here I have plus 2. So I will have 5 electrons there to balance my charges. Now what is it that I want to cancel when I combine these all together? I want my electrons to cancel. So I'll multiply that by 5, multiply that by 3. And then you can go through and do that. Yes, Wakas? That's why I added these electrons. The electrons balance, you add them to whatever side you need to balance that out. So like plus 8 minus 1, this was plus 7. And then this was plus 2. So I added the 5 electrons over here. But what you might be thinking of is, okay, when I go through and I cancel everything here, my electrons will cancel out and I'll end up with 5 aluminums, 24 hydrogens, 3 MnO4s, and then on the product side, 5 aluminum ions. Whoa. 3 Mn2 pluses, and 12 waters. Okay, this is if it's balanced in an acidic solution. So if it's basic, what do I have to do if it's basic? I need to add what? Hydroxide ions to balance out. So like if I've got 24 hydrogen ions over here, then I've got to put 24 hydroxides. Where do I put the 24 hydroxides? Both sides, okay? Both sides, and then you combine H pluses and OHs to give you waters, and then you can cancel out some waters and so on, okay? Quick review. Any questions on that? Yeah. All right. Let's talk about galvanic cells, batteries. We're going to draw some pictures here, talk about what's going on with these different half reactions. So this is all new stuff. All right, we're talking about in chapter 17, electrochemistry. It's about electricity. And all electricity is just moving electrons. And so with the half reactions, you've got one side that's going to be giving away electrons, another side that's going to be taking the electrons, and that's where the electron flow comes from. A battery has a separate cell for each half reaction, and they're connected so that those electrons can flow. So like if we were looking at this, my reaction had 3 electrons over here, and maybe this one needed some electrons over here. They would just be connected with a wire so that those electrons could flow. A lot of what you guys have to do with this is drawing diagrams, labeling all the different parts of the cell, and showing the flow of electrons and all that given the cell reaction. Okay, so I've got zinc and copper here. Zinc going to zinc ion, copper ion turning into copper. Okay. We're going to go ahead and draw the 2 cells here. Okay, now each half reaction has a separate cell, remember? So if I split this up into half reactions, I would have, and it doesn't really matter which side I put where, but zinc, and that is turning into zinc 2 plus 2 electrons. I need to add those electrons in there to balance charges. The other half reaction is my copper 2 plus, gaining 2 electrons to become copper. Now, in these separate cells, you would have a solution of some sort that would give me these ions. So it might be like zinc nitrate. So I would have zinc ions floating around in here, nitrate ions. This doesn't matter so much as it just is something that's going to be soluble. Over here, it might be copper nitrate, so I'd have copper ions floating around, nitrate ions floating around, and I would have electrodes made of these metals. So here would be zinc, here would be copper, and they would be connected because we need to allow the electrons to flow, and there would be some kind of meter here that would measure or read voltage numbers. Okay, now looking at these different half reactions, it's zinc that's getting rid of electrons, and it's the copper that's gaining the electrons over here, just based on the half reactions of the overall cell reaction that I have up here. So since I'm losing electrons over here, I want to label that flow of electrons in that direction. So that's kind of a common thing that you'll be asked is what's the flow of electrons. So you just want to pay attention to which side is losing the electrons. Okay? Now, what else? Let's talk about just 2 terms real quick, the anode and the cathode of the battery. Another question would be another common question, which one is the anode, which one is the cathode? Okay, the anode is where oxidation occurs. The cathode is where reduction occurs. Okay, easy way to remember this. And ox. Did you do this before? Red cat. Oh, I thought I heard Jonah say it. If you remember an ox, then you can remember that the anode is where oxidation is happening. If you remember red cat, then you'll remember that The cathode is where reduction is occurring. Yes?
Which of the metals, like you have the zinc and the Zn2 plus and then the copper and the Cu2 plus, which one of them is forming the ion versus forming the metal?
It's based on the overall cell reaction. So this is the one that's forming the ion.
Okay.
So you just look at the overall reaction, which will be given to you. And then that way, now based on those definitions, I can figure out this one is being oxidized over here. So this is the anode. And this one is being reduced over here. So that's the cathode. Okay, now, there's something missing here. What I have set up right now is just all of these electrons are just coming over here. Now, in each cell or each side of the cell, it wants to have the charge equaling 0. So this wants to keep an overall charge of 0. This wants to keep an overall charge of 0. So there has to be some way to balance that out. So every battery needs something called a salt bridge. And a salt bridge is, well, here we go. It's usually a salt bridge. Sometimes they have like this porous little disc that runs from one to the other that allows the flow of ions. So you might see it that way also, but they make a big deal about the salt bridge. So here you go, this definition of what a salt bridge is, and then we'll kind of label some stuff in there. And then talk about how to figure out the overall voltage of this battery. And then that'll be it. Okay, so this salt bridge would have some kind of electrolyte in it, some kind of salt. It doesn't really matter what it is. Maybe it's sodium nitrate is in there. Now what it does is it provides this flow of charges so that the net charge in each side can be 0. So since this side is the one that's losing electrons over here, then out of the sodium nitrate, it's going to add the negative ions to this solution because it's going to be losing negative charge. This one over here is going to be, the sodium ions are going to come in here to balance out the extra negatives that are being added so that the overall charge there is 0. So that's also a question as to like which ion is going to go in which side, and it needs to be to balance out the charges. All right, now the other question is, what is the electric potential of this battery? Electric potential is abbreviated with this weird little E thing. And those values, we're looking for basically voltages. Now, this is a pretty simple thing to do. You are given, in your book on page 796, is a chart of standard reduction potentials. And it's also in that, that packet that I gave you that you're given on the AP test. You're given a whole big long chart of reduction potentials. This is where we're going to use it. So you have all of these things. This is on page 796. And you're going to look up each of the half reactions. And the cool thing is that they actually already have it balanced for you, like with the waters and the hydrogens and all that. So it gives you, or it kind of takes away that step of having to do it. So what I want to do is I want to look up my two half reactions. So for this one, my half reactions were zinc turning into zinc 2 plus and 2 electrons. And I had copper plus 2 electrons giving me copper, okay? Now the chart is reduction potentials. So it actually only gives you the reduction version of this. So like if we find zinc on this chart turning into a zinc ion and if you find this on your chart, it actually gives you the zinc ion plus 2 electrons because it's the reduction potential, right? Gives me zinc. But my half reaction for the cell is the opposite of this. It's flipped. It's zinc giving me zinc 2 plus 2 electrons. So since it's flipped in my half reaction, I can also flip the voltage value that it gives me. So since it gives me negative 0.76, but it's the opposite, then my electric potential for this would be plus 0.76 volts. Does that make sense? If you look it up on the chart, and when we looked it up on the chart, it was this. Zinc 2 plus 2 electrons gives me zinc. But according to my cell reaction, this is the half reaction that I have. So I also have to flip the sign of the electric potential. Okay, now I can look up the same thing for copper on my chart, and I will find it right here. Oh wait, nope, that's the wrong one. Where is it? Copper, here we go. Copper 2 plus, wait, is this right? Yep, copper 2 plus an electron gives me, oh nope, that's not right. This one, here we go. Copper 2 plus, you have to find the right one. Plus 2 electrons give me copper, metal, and that electric potential is 0.34. And then you just add them together. So then the electric potential for the entire battery would be 1.10 volts. Okay? So you have to look up each half reaction in the chart. If it needs to be flipped, flip it. Also change the sign of the electric potential. Add them together. 4 questions for homework, page 8, 31, 25, 27, 29, 35.